Hello, everyone, and welcome to Faces in FinOps, sponsored by our friends at ProsperOps with myself, Stephen Old. And today I am really excited to be joined by a real expert in the FinOps and AI field. We've got with us Adam Richter from AWS. Adam, thanks for joining us. Please tell us a bit about you and what makes you a face of FinOps.
Hey, thanks for having me. I am a solutions architect at AWS. I work on the optics team where we specialize in cost optimization and work with customers all day, every day, trying to help make sure that they save money on AWS. And I've also gotten kind of deep into this AI space starting around 2 years ago, where I built some stuff for our team and then also have just been staying on the bleeding edge of what are some techniques that we can use to run these things optimally.
So interesting there. So have you been using AI for FinOps as well as then doing FinOps for AI?
Yes, both sides of those coins can kind of be a little bit confusing for folks because the terminology is so close. But the simple way I explain it is FinOps for AI is just using our FinOps practices to manage AI costs. And then AI for FinOps is kind of that flip side. It's how can we use AI to help do our FinOps job better, faster, maybe automate some of the things that we do or surface unique or interesting insights easier. So that's at least the way I interpret them. What about you?
Yeah. No, I agree. Um, I think, yeah, AI for FinOps is about how do we integrate AI into what we do? How do we use it in the way we should any part of the business to improve our efficiency and our output? I know a lot of people say that, it can't do what I can do. If it's to do with numbers, it can. Like straight off the bat, it can. But then, yeah, FinOps AI, which is where I've spent more of my time in the last 2.5, 3 years now, is around how do we manage this area of growing spend, and that's what we're going to focus on today. But we maybe should do another episode another day about like where we can do AI for FinOps as well. Um, with that in mind, then, to your mind, in your experience over the last couple of years, what are the biggest differences about doing FinOps for AI versus FinOps for cloud and other things?
I think I'll answer that a little bit differently because I'm a big advocate of trying to explain the similarities. Because I think when we started having all these or like AI workloads come online, initially I think there was a little bit of a knee jerk reaction thinking that it's so different. We've got to handle
Mm,
this differently. But the reality of it is like when you boil it down to like the fundamentals of what's being used, it's just compute if you're running GPU or accelerated compute instances of any kind, which we manage very similarly to how we currently manage any compute. And then even if we go into managed services like our Bedrock, that's like a performance based pricing. So think like Lambda, right? Lambda we pay per
mm.
second, Bedrock we pay per token. So a lot of these things are concepts that we're already familiar with. They're just slightly tweaked, right? A little bit different language, but the principles I think are the same. So I guess I would answer that to say I don't think it's that different, really.
I think that's an interesting point of view. I think that's really true if you're running AI in the public cloud. The reality is, most people's interaction with AI as it stands, like the person on the street, is probably with a user based AI, which does get handled differently. And so if you start looking into the SaaS side of this, you've got FinOps for SaaS, which starts looking at two types of SaaS even, right? So we're getting into breakdowns of breakdowns. And unfortunately for us, AI fits into both of those. We have user-based SaaS, buying your Copilot, your Claude, your Chat GPT, whatever else you might be using, Replit, whatever it could be. Um, but then if you build out like, I'll just give it a little example. I built a small language model that had all of the SPLA Windows Server licensing in it because we had a person who was getting asked questions all of the time, and we are like, do you know what? You just know that document verbatim and then answer it back. So we built a model, so we chunked that up, and we then created a query engine against that. And then I put a large language model in front of it to take the chunks that it fed back and then to put a concise answer together. You get charged very differently when you use a GPT or a large language model like that as consumption-based SaaS than you do when you're using it as a user as well. So, and then also there's then the argument that often running it on-prem can be efficient, depending where you are and those kind of things. So one of the things that I think that's a bit different about it isn't that it is in itself different in any of the particular arenas that it's in. It's the fact that it's in all of those arenas and in all of those scopes. So the FinOps for AI scope is interesting because actually it kind of is its own scope, but it's also part of all of those other scopes, unlike anything else I've ever come across. I find that really interesting. That makes it more interesting, and in arguable case, more similar to more things than different, I suppose.
I had a question though on that. Like in that example, really the pricing would boil down to either like some kind of user license based pricing or some kind of consumption, like per
100%.
token, per API call, whatever it may be. But at the kind of fundamental level, that's how you were consuming these things, right?
Yep, yep. And even on-prem, you're still using GPT, but your data sets are different, and and the way you get those data sets is harder. I mean, finding some of the data sets when you're using this as a direct thing, not from not from the native AWS stuff where it's coming where you expect it to come, but if you go outside of that as well, actually just getting some of this data back can be quite challenging in comparison. Like the AWS stuff is fairly simple. It comes in a form that we are used to seeing. Usage times rate equals cost. It is the same concept, and it's just more that in organizations where FinOps hasn't approached things like SaaS yet, you could basically have AI costs being managed by multiple teams. I guess that's my point, because you might have your SAM team managing it and maybe your on-prem team managing it. And so how do you get a holistic view across your organization of value? I think
Yeah.
that's the problem a lot of people face, right?
Well, I think you're also touching on kind of the element of customers that are thinking multi cloud or that have a
Mm,
hybrid setup where they have on prem and cloud. Like at that point, it can be challenging to try to collapse all those things into one set of visibility, right? To understand the
mm,
costs and how they bill and maybe your unit cost and how they compare across each of those. And that's some of what the like FinOps Foundation with their focus framework is trying to help address some of that by standardizing how that data gets ingested and compared across both cloud and SaaS platforms. So for those of you out there that haven't really heard of that, that could be a solution, but it's still not one size fits all, right? We've got so many of these new things coming online so quickly that it's going to be a rapidly evolving space.
yeah. You mentioned about like, so we have the versions of costs, and one of them is basically a per token model. Do you think there are many other services in cloud that have the same kind of impact in terms of the tokens can be driven by users and poor usage drives expense? That makes sense of the question?
Kind of, I guess
Yeah.
if I'm interpreting it, like interrupt me if I interpreted it wrong, but like I see a lot of the cloud-based usage as, and that's the benefit of the cloud is just consumption oriented. So whether it's hours of an EC2 instances, maybe seconds of a Lambda function, or like with DynamoDB, you have like read and write capacity units, right? So it's all just somehow breaking down that service into like how you would consume it into a chunk. And I think that's a benefit, right? Because when you're running stuff on prem, like you have the full cost of whatever that is, whether you need all of it or not at any given time of
Mhm.
the day.
Yeah.
Whereas with the cloud, you're generally only paying for what you're using unless you're, doing a commitment or some kind of other model there. But you're generally only paying for what you use. And when if say you have no customers in the middle of the night or your website's slow in the middle of the night, then it can scale down and ideally you pay less. So, so hopefully
But
that'll be the
if,
case here too with AI.
yeah, but let's look at tokens, right? So if we use a generative AI model, and there's some research that shows, and I can't quote the research, so let's take it as a indication rather than gospel, right? It said something like, if you train people to effectively prompt, it can reduce the amount of prompts to get to an answer by up to 20. Right. So you might be able to do it in one or two versus 20 plus, right? Tokens carry context, right? So that 20 versus that one isn't 20 times more. It is a lot more. And I don't know if there's any other service in cloud vendors where poor usage, poor training can create such a cost differential. That's kind of what I mean. Does that make sense?
Yeah, when I've had a similar discussion to this with another architect, and we were talking about like how much we should emphasize prompt engineering versus how much just a smarter model can ascertain what we're asking and get the right answer. And I think, as these models get more sophisticated, for one, it requires less quality of a question. But then two, like depending on the use case, and I talk about this in some of my presentations, if you're fine tuning a model or using RAG, retrieval augmented generation, things along those lines may make the model more sophisticated in answering the types of questions that your customers are asking. And that's absolutely a savings and a benefit because, to your point, if you can get the answer in one question versus 20, that's a lot less tokens in and a lot less tokens out, which mean savings, right? Secondly, like the type of model you pick matters too, right? If it's more or less verbose. 'Cause many of us have went to a model and asked like simple question, like an example, like, "Hey, Matt, how many bags can I take on such and such airline?" And a succinct answer may just be like two, whereas a long answer might be, "Well, you can take two bags. They have to be this dimension, this weight. On this day, it's different than that day." Like you get this big long story, and sometimes that story matters, but other times it doesn't. And knowing that setup in your environment and what your usage pattern is and what your customers will be coming in to ask could be a huge difference in savings depending on the model you pick as well.
Yeah. I about 2 years ago, I built. It's nearly 3 years ago. I'm just making myself feel older. I built a model to help demonstrate to people the way they could consider managing AI costs. And it was at the beginning of generative AI becoming a bigger thing. And I was working with some big manufacturers who were like, "How do I stop myself burning money?" And I kind of said, "Well, what answer do you want to learn? Oh, we don't know yet." Okay. And what data set do you want to use? Oh, all of it. We've kept everything forever. I was like, they're the two worst things you can do. But beyond that, you make some good points. So there is, there's prompt engineering, but model choice and understanding your data architectures are absolutely critical parts in the path that I think people with excitement to do something miss the importance of maybe a bit of preparation, a bit of thought, a bit of engineering to actually start with something that could be relatively efficient. Because I think a lot of the first cases I see are rushed and therefore can sometimes damage the use case of like why should we use AI because they are more costly than they needed to be because of a lack of upfront planning. Do you
The
see
thing
that?
this reminds me of is that, like, so generally speaking, input tokens are less expensive than output tokens in most cases. That makes sense because input tokens, you're just receiving the prompt or the question, and then output tokens, the
Generating.
model actually has to, yeah, do the inference, right? And using simple techniques like you could still use a very intelligent model that's large, but adding in like a system prompt into your setup that says, be succinct, right? Provide us, a simple answer without any reasoning, without any explanation. And that alone, like in some of the testing that I've done, like it saves
Massive.
75% on the output tokens and get a very similar quality answer. And if you want more detail, you can ask a follow-up
That's great.
question. Say, give me more details on number two of whatever you said, right? Like, so that's one thing to think about. Another thing that comes up commonly is though is because you can call it kind of like an input token tax. If the type of solution you've built is going to be like a multi-turn conversation or something that's carrying over context in some way, shape, or form from some previous interaction, all of that previous output now gets injected into the prompt as an input. So over time, that input can grow quite large. So even though input tokens are less, in some ways that models are attempting to deal with that is summarizing previous input or letting like doing like a rolling window where some of the previous input kind of falls off. So there's some different things that could be done there to help compress that. And I guess that just reminded me of one other thing to interrupt you is compression matters too. There's solutions
Mm.
out there where you can ask it to compress the input or the output because the AI doesn't need it in the exact way we ask it. There's a lot of words in what we give it that it doesn't care about and it doesn't need to formulate a good answer. And by using compression tools, it can strip a lot of that out and kind of summarize your prompt or your question or the output to give us, less tokens in, less tokens out.
100%. I think one of the things that we contend with in this space is that, as I said earlier, a lot of people's um, current activity with AI is probably on their own either free to use or relatively cheap pay to use monthly user subscription that they have themselves. Where, I mean, occasionally, if they're using it heavily, they might hit token limits, i.e., they get a lesser answer, but they're not being charged more. They're not feeling that cost. And so when they flip into a business setting where that does have a cost and a direct cost, their brains aren't trained to think about that because of their other lived experience of working with AI and generative AI.
That's so true. And that's, I mean, that's even my experience, right? $20 per month. It's kind of an all you can eat for all practical purposes of various different models and solutions out there. But really, behind the scenes, that business even is having to
They're bleeding
process,
costs.
yeah, that input and output tokens. And that's going to be the case true for any business really that's running an AI solution. So it's important to think about what you can do on the, and that's why a lot of my answers are, I guess, through the lens of, AWS and the cloud. What can you do to do that more cost effectively so that you can serve either more customers a better answer faster, or that you can do it at a less cost per token, or whatever that looks like?
Yeah. I'm going to go back to something you said earlier because you said it as part of a wider conversation, but I do think it's something that people haven't got their head around fully yet when I speak to people. And I'd be really interested to see how you describe it because it's probably better than ever I do. You talked about RAG, which is obviously more cutting edge than maybe some people are getting used to on the other side. Can you talk people around the benefit of RAG and what it's doing and why it really can help a lot in an organization?
Yeah. So the best example I could give of this is like a couple of years ago when we used to interact with models, they only had the knowledge that they had when they were trained. So if you
Mm,
asked a question about some kind of recent event, generally they would not know how to answer that because when they trained, that data wasn't in their data set. They didn't know the future. But now models have been given tools to where even if they don't know the answer, they can do like live lookups to the internet and do different things to pull in that context. So that kind of iteration of models has decreased the need to pull in as much external data, but it's still unaware. Models are unaware of any private data that you might have within your organization, or context that's not public in some way, shape, or form. And that's where things like RAG are really useful. You can, instead of having to retrain the model, you just give the model a data set of something that's valuable to it that'll help give it more context to be able to answer questions better. That data gets indexed, typically stored in some kind of vector database, which just think of like it's like a fast lookup database so that it can get
yeah,
answers quicker.
holding chunks.
Then when you give a prompt to it, it looks across that RAG data set, pulls in any context that's relevant, kind of combines it with your question, and then gives it to the model. So then at that point, the model has a lot of additional detail that it might not have had otherwise, so that it can give you a better answer. The alternative to using RAG would be like a fine tuning or custom training, where now instead of that data living outside of the model in like a RAG data set, it's been trained into the model so that the model knows it inherently and doesn't need to do a separate lookup or separate context kind of being pulled in each time. The two different use cases of like, well, which one should I use? Right. Because they both kind of accomplish the same thing. If you don't want to do fine tuning and customize a model, RAG's a great setup in that case because you don't need to change the model. It's just adding that RAG context in. So it's like a kind of a sidecar. Whereas fine tuning results in you running a custom model that's now been trained,
Yeah,
has different weights for different things, and it's now no longer just your like standard kind of out of the box model.
yeah. Indeed, and the things with RAG, sometimes you have to manage the site. Like you can't let that piece get too big, or it
Yes.
starts getting in the way.
Well, good point. Because so every time somebody asks a prompt, right, it's having to do a search through that whole RAG database. And if that has gotten very large, that search can take longer, be more costly. So when you're indexing data for that, you want to make sure that you're only indexing the data that it needs, right? Don't point it at a bunch of extra data that's not needed. Lifecycle stuff out. If there's data that's old and been replaced by new stuff, get rid of it so that it's doesn't continue to be part of that data set. So it's basically good data hygiene. And then if there's new things coming online, make sure that those things get added to the data set and indexed so that your index is current. So RAG can be really good if the data that it's referencing is changing frequently. Because if it's changing frequently, then it can just point to that data set and update pretty dynamically. Whereas fine tuning, you'd have to retrain it, right?
And RAG can be very cost effective when used correctly.
It can, and especially on the AWS side, I've been testing recently. We introduced S3 vectors, so it's
Mhm.
like
Oh,
RAG.
really?
Instead of using OpenSearch, it stores the RAG in S3 instead, and it's not quite as fast as using OpenSearch, but
Imagine
it's
so.
it's in my testing at least, it was around 90% better price. So price wise, excellent. If latency was a huge factor, maybe OpenSearch would be a better fit in that case. But in the testing that I'm doing and the internal tool that I built, like a couple extra seconds is not really going to make or break, the solution that I'm building. So it's a wonderful solution. in that setup, especially with the additional cost benefits.
Yeah, fantastic, man. I've built some in like Postgres vector before and bits like that. So people don't have to go too far away from what they know. I mean, in S3, that's fantastic. This stuff isn't like rocket science. You do need to learn some of the pieces, but you can use building blocks that you're comfortable with and know already, which I think can be really helpful.
Yeah, a lot
But
of it's
let's go.
automated. You just point it
Yeah,
at a data source and it indexes it and kind of takes care of it
exactly.
for you. So it's not something that you have to be super knowledgeable. There are things that you can do with chunking and other stuff to make it a little bit more advanced, but to get started doing it, it's pretty easy.
And even chunking's not that complicated, right? You
Mhm.
can you can script out chunking pretty easily, as I've learned. Um, One thing I think people will want us to listen to, one thing I think people love in FinOps in general is KPIs. What do you think are some useful KPIs to be considering when you're stepping into the AI on cloud game?
So I guess a couple of different ways you could look at it. They're the fundamental like service-based KPIs. So that might be just like price per token, price per inference, like per
Yeah,
kind of question in
big
and
top ones,
out.
I know.
Yeah, price per, GPU, like basically service high level things so that you can see how you're tracking over time, whether you're using a more efficient model or you've purchased a commitment, you're getting a better price now on GPU. Like those things at a high level just tell you how you're tracking, like as a business. But the metrics that I think are more important are tying those to like what the solution's actually being used for from a business value, right? So cost per, input from customers or, cost per, report generated, like whatever your solution actually is that you're providing with AI as a business, if you can tie it to that and create metrics around that, that's more valuable. Because,
Yeah,
and the example I use often is like the solution is like isn't necessarily always just reducing cost. Because if I told you, for every additional dollar of cloud spend, your business was making $2, you would never
and
want the
it's a good
costs to
decision to
go
have made.
down, right?
Exactly,
Because
exactly. Yeah.
you're in some cases costs go up because you're serving more customers or doing more things. So yes, it would be maybe great if we wanted to reduce some kind of efficient, a commitment or something to bring it to where it's 75% or 75 cents for every $2 we make. But these are things to think about, like tie it to your business in any way, shape, or form you can, so that not only do you know the value of what that AI is producing, but now you've linked the value to the cost.
I mentioned to you before we came online. I found an interesting paper that was released. Let me just check when it was released. I think it was August, 29th of August, so very recent, and it's on the archive of Cornell. It's written by someone called Alicio Curcio, and it talks about the levelized cost of AI. Now, levelized cost of is something that's existed for a while in other areas. I hadn't come across it. It hadn't been in any of the worlds I'd gone, but it's quite an interesting kind of concept around how maybe you can do some of this stuff in the multi-cloud thing. The areas it's been in before, by the way, are levelized cost of electricity and of hydrogen in those kind of worlds, right? Which is interesting that someone's taken something so over there and then applied it across to AI. But there are, some isomorphic economies relation of cloud and energy, at least electricity. But the idea is, you LCOAI is capex amortized plus the opex across the period over the number of valid inferences. Generally, is the idea. I can send it to you afterwards, but it's interesting. People go have a look at the paper. Um, I think it's probably not needed as it stands in 99% of the organization I've spoke to in this space, but it could be an interesting future metric
Yeah,
to
I don't
look
have a
across
lot of
the board.
experience with that metric, but what it brings up for me at least is like there is kind of a big like initial investment with AI if you're doing your
Yeah,
own training, right? Because
exactly.
you're launching a bunch of say accelerated compute instances, you're spending a bunch of cycles training. So it's like you're putting in a big initial investment to ideally get an output of something that is a fine-tuned or trained or model that makes sense for your business or your use case. And you'd kind of have to level that out or spread that out, across the value of however long you run that to truly see like the costs spread out over time. And similarly, though, what I like think a lot of people overlook on the kind of the two sides of that equation is once you've completed all that training, whatever it took to make that happen, well, now you have to run whatever workload it takes to do the inference. So that when people are coming in and asking questions to that thing or whatever the interaction is going to look like, if it's something agentic or whatever, it still has to perform that like processing to be able to come up with an output. And that's going to have more of a kind of a steady state, probably predictable cost that will scale up and down according to the workload coming in. But yeah, that's an interesting to look at kind of the I would say like the TCO, right? What's like the total cost of this thing over time and then really understand that so that we're not short-sightedly looking at just one component of the AI cost and not seeing the big picture.
I think that's one of the things we've seen. A lot of people I speak to kind of go, "I'm struggling to prove the value of my AI," and I think some of that is a lack of upfront measurement in terms of what is it replacing and what was the cost of that thing, or if it's an investment to do something new. I think that's a bit easier. If it's an investment to have a new capability, then you look at the benefits of that capability. But when it's replacing something that's already existing, you've got to actually spend a little bit of time, even if it's in the time while it's being built, etc., to try to get a proper understanding of the cost of what exists to then be able to compare it. Because otherwise, you have no idea if your investment's valuable or valid in this regard.
I think
And yeah, that's interesting.
there's a lot more value I think to this stuff than is currently being realized. I don't think like, a lot of these large AI vendors would exist and, it would have such high utilization of people like anybody a lot of people that I talk to, they use this stuff daily at this point. And if there wasn't truly value, like I don't think that would be happening, right? People would try it a couple times and then probably never use it again for one. And then secondly, I think a lot of the value in these things are like based on time in some cases, right? They may be saving us time or speeding up things that we would normally do and making us more efficient. That's not as easy to quantify as like, we're pushing out more products on a product line or something like that. But that aside, I think we're going to see that equation change pretty heavily as we're shifting into more of this like agentic space where now we're not just taking AI and making it a like a conversational thing that we're interacting with. Now it's actually getting like, hands in a sense to go do things and automate stuff. And that output's going to be very tangible. Like I think we'll be able to track that in a very meaningful way of however many X that this thing produces.
Actions or whatever. Yeah,
Yeah, exactly.
yeah, I agree. I think it's interesting. I think I'll give a small example. So I built out an internal tool, and I'd done it using the coding languages that I know, and I literally put into my AI of choice, how can I make this code more efficient? And it suggested changing language to one I'd never tried before. I kind of thought, I don't know about that. That creates some risk. And I thought, no, show me how, teach me how, and explain why. And I learned in you know, I, that would have taken me months and months before. Took me a couple of weeks, and now I feel that robustly that I understand what's going on. And yeah, I had to know what questions to ask and drive it, but the value that's added to me, to the tool, the whole thing is massive. And so these things can be really so powerful. And in the end, it's actually allowed me to drive a cost reduction because it is a significantly slimmer and streamlined and better because I, you know, took the chance on something that before we wouldn't have done because it had been too much work, to
Yeah,
refactor.
I think coding's been a big place where we've seen a lot of like value being driven. And I had a similar example to you, like when I'm trying to create scripts to automate or do different things. Previously, I would have done like a bunch of different internet searches and I would have, read through various forums to like kind of cobble together the pieces of code to do what it is that I wanted to do. Now I can largely like vibe code it out, right? I can go into a some kind of AI and tell it explicitly what I would like to build, what language even, and like it gives me usually 90% or even in a lot of cases 100% of what I'm trying to accomplish, and that's saving tons of time like for me and now I have a script that I can use, whenever I need to automate some kind of function. And that time savings alone is extremely valuable because now instead of spending time coding, I can spend more time on the things that matter to like my customers and delivering value.
Exactly. And I think I'm not seeing organizations grab that benefit yet, but I think that's one of the things we'll really see in the next couple of years. And that'll be one where I think you can probably really demonstrate some value because there could be some real tech debt unlocking that happens over the next few years with empowering with this. Um, we talked a little bit about um, inference and tokens. Last thing I want to talk about, 'cause I'm just conscious of time, and this would be interesting to speak to with you as a someone at a hyperscaler cloud. I think currently people are using AI in a very unstructured way in terms of how they build their models and the time they build them and how they run them. And while on demand is massively useful and very powerful and etc., I do think that as organizations get to a point where they run more models and they have more models, and I'd be interested in your view about like, do you think people should try to build one to rule them all, which is not my experience or advice I generally offer, but I'd be interested in your thoughts. But as you get to, and if you do go down the route of having multiple models and then also the retraining and the pieces like that, that actually maybe we can think in a way where while we're not resource constrained, imagine we are slightly, so we could maybe use capacity better and therefore maybe use things like reservations better if we're getting to a point where we are training regularly enough and using GPUs regularly enough rather than all the bursting that currently happens. Just be interested in your thoughts on some of that.
Yeah, so two sides there. One thing is I'm very like multi-model. Like I think that's important. I think as fast as the space changes and we see like the model costs going down and the intelligence of them going up, I don't think it's wise to lock yourself into one model for a long period of time. I think you'd be doing yourself a disservice because many of the things that you trained on or many of the complexities that you're dealing with might just get solved in like the later iteration of a model. So definitely model flexibility is important. But at the same time, like if you're running accelerated compute instances, those are like the engine, right? Like you can throw different models at them. And I think we will see over time that, like, yes, that compute that you or that accelerated compute that you're running can serve more things potentially dynamically. And in our case, like, we have like SageMaker Hyperpod, but there might be other orchestration things that people build to take that accelerated compute. And now we may have five different business units. One's doing some training, the other three are doing inference, one's doing, experimental project. And now we can maximize the usage of that accelerated compute by having that, yeah,
Right,
usage
slots.
get orchestrated so that we don't
Yeah.
have downtime. Because maybe that
A bit like we
experimental
used to with
project could,
supercomputers, right? That's how we used
yeah,
to have if you're in
exactly.
universities. Yeah, exactly. Yeah.
Same concept. Yeah. So I think we'll see more of that so that we can get more value out of that. I think a step toward that I advocate often is get your monitoring in place. Like I think it's important to understand like the GPU utilization and the other metrics so that you can see like when are we using this and how much downtime do we have, because that alone might tell you like, oh, we're running 10 of these things at 50%, we could be running 5 at 100% instead. Or we have got 50% capacity free on that 10. Do we have another project that could take advantage of that? And I think until you have that visibility, you can't properly manage or make those business decisions. So it's important to, like, as a step on that journey, if you don't already have great visibility there, like go ahead and start working on that first. And then you can kind of make that decision of how to use it.
Now, interesting point here. So I know you're in the optics team. So do you work on cost intelligence dashboards and Cora and that kind of stuff?
And we use them, but I don't work on them like
Okay,
like support
but
building them.
yeah, do you see some of the stuff that you're working on and some of the AI stuff moving more into that space and there becoming some views on there over time? Do you think?
Yeah, I think more of this stuff is becoming like built into, I would say, like native tooling visibility wise. Even our compute optimizer, like this is kind of a lesser known thing, but if you have CloudWatch agent installed with the NVIDIA, say, metrics turned on for some of the GPU instances, Cloud Compute Optimizer will automatically detect that and tell you if there's any right sizing recommendations around those things. So it's part becoming more and more part of our native tooling, and dashboards included, right? Like there's already dashboards in the cloud intelligence dashboards for some of this AI stuff. I'm sure there's many other dashboards that others companies have built out there that include these types of things too. But keep in mind, a lot of those dashboards are built off of like cost and usage reports and cost data. And cost data is great. You can see like utilization, right? We talked about earlier how many hours, how many tokens, but you can't always see some of the more advanced things like how well the GPU is being utilized, or maybe how many invocations that and say in something like Bedrock that it took to result in that amount of output tokens. And that can make a big difference, right? Because if you have one invocation for 10,000 output or 1,000 invocations for 10,000 output, that tells you a little different story, right? Like we're either getting very verbose output for one person, or we're getting maybe reasonable output for 100 people. So so knowing the more granular stuff is important, and that usually is a bridge a little bit further than the just kind of the default dashboarding.
Yeah. So using things like CloudWatch logs, pulling that stuff in,
Yep.
enriching your data with those. Yeah.
Yeah, I think CloudWatch for us is key for getting some of that more granular data. And these and I think that's the right move with these kind of things because they're like again, to understand that total cost, of operation of these things, the more data that you can get into how these things are being utilized, the better you can understand the usage patterns. And once you know that, now you can get to that value conversation where you can explain what kind of value this is delivering.
Fantastic. I'm conscious of time, Adam. I've been super interested. Hopefully, people have been as interested as I have with all the wonderful things you've had to say. Um, have you got any final thoughts you'd like to share with our audience?
I would just add like the visibility, right? Like get that into place as soon as possible if you don't already, because you can't, manage it if you can't measure it. Like do that today.
100%. I love that. Well, thank you so much for joining us and imparting your wisdom. Watchers, listeners, our audience, thank you so much for being here. Prosperops, thank you for hosting us. It's been a pleasure to be here with you. Thank you very much.